So what we're doing today is something totally different than what we've done before. But we're going to actually be approximating logs, which means not all of the logs are always going to work out like they have been so far. Okay, and then we also are introducing a new theorem called the change of base theorem. Okay, so we're actually going to be able to change the bases of our logs to whatever base we want to. Okay? Alright, so first thing we have to recognize is, for example, if I have log base 2 of 10, I set that equal to x, and that's the same as 2 to the x equals 10, correct? We come up and around, 2 to the x equals 10?
Yes.
Okay, can you solve that for x?
No.
I can't. I can't think of anything that you could raise 2 to get an answer of 10, right? Okay, so what we have to do here is approximate the value. Okay, so looking at this, we know that 2 to the third is equal to 8, right?
Yep.
And 2 to the fourth is equal to 16.
Yep.
And I want my answer 2 to the x to be 10, which falls between 8 and 16, correct?
Yep.
So we know that for the exponent x, it's going to be somewhere between 3 and 4, and that's all we need to know.
Okay.
So that would be your answer, between 3 and 4.
Okay.
Okay? So for an example, letter B, we have log base 3 of 25. If I set that equal to x and rewrote it as an exponent, that would be 3 to the x equals 25, right? Come up and around. 3 to the x equals 25. So we are trying to find what two integers x is between. Okay? So let's just start listing things. What's 3 to the first power? 3. What's 3 to the second?
9.
9. What is 3 to the third?
27.
27. Can I stop?
Yes.
I can. 25, my answer, falls between 9 and 27, right? So I know that my exponent is somewhere between 2 and 3. And that's your answer. Because the question just asks between what two consecutive integers does x lie. So you're just trying to find between what two integers the exponent will be. So in this case, 2 and 3. Does that make sense?
Yeah.
Okay. So we have two examples for this. Okay. Log base 7 of 9. And so let's do that. We set the whole thing equal to x. So that's going to be 7 to the x is equal to 9.
Can't really see it. Right there.
Sorry, there you go. So we rewrite as an exponent, 7 to x equals 9. So let's just start listing stuff. 7 to the first power is 7. 7 to the second power is 49. I can stop there, right?
Yes, you can.
9 falls between 7 and 49. So my answer lies between 1 and 2. Will you guys do number 2 by yourselves really quick? Okay.
3 to 20 is 5.
All right. Okay, how would I rewrite this as an exponent? 3 to the x equals 200, right? Okay, so let's start listing. 3 to the first is 3. 3 to the second is 9. 3 to the third, 27. Okay, we're not there yet. 3 to the fourth, 81. 3 to the fifth, 243. Can I stop yet? Yeah, so what is it between? 4 and 5.
Okay.
No. Okay, will you read it for us? This part right down here.
In the above problem, different bases were used. Bases 2, 3, and 7. Because calculators have limited buttons and cannot work problems in all the different possible bases, they have chosen 2 bases. Bases 10 and base E. Remember, base E is an irrational number like pi. But remember an approximate value of 2.718. You can convert all Logarithms.
Logarithms.
Equivalent logarithms. Or E. Below is the formula to convert logarithms.
Thank you. Okay, so Michael, can I borrow your calculator really quick?
Yeah.
Okay.
I clicked a bunch of buttons on it and laughed.
Okay. So, guys, what this is saying is we have lots of bases for logarithms, right? We can pick any positive number, correct?
Yeah.
Except which one? No, any positive except 1. Okay. Any positive except 1. But, okay. But on a calculator, there's only 2 buttons for logarithms. Log, without a base, which means it really has a base of 10, and natural log, which is log with a base of e. Those are your only 2 choices. Log and natural log. Okay? So, log and natural log. There we go. Log and natural log. Because calculators only have base 10 and base e, we have what's called the change of base formula. Okay? So, if I give you an example log, so we have the change of base formula. So if I give you an example log base c of a, okay? The base is currently what letter? C. To change it, we can actually write it as a fraction. We can take log of a, that number goes on top, over log of c. So your base always goes on bottom. Okay? And that changes the base of it. What's this base right here? What do we change it to base of? 10. Good. Okay? So, you'll notice no base is given. We can use any base. So, for example, if I have log base c of a, I can apply the change of base formula and give it any base I want. I can rewrite it log of a over log of c, but that's the same as log base 6 of a over log base 6 of c, or log base 4 of a over log base 4 of c, or log base 8 of a over log base 8 of c. It does not matter. We can pick any base we want to. The only thing we have to remember is that this number will always go on top, and your base will always go on bottom of the fraction. But that's your change of base formula. Okay, so that's in here right now. I put it in a big box for you and made it bold. So the A always goes on top, C always goes on bottom. We can pick any base we want to, but we have to remember that B has to be positive and not equal to 1. So as long as our base is not 1 and is not negative, we're good to go. And this will work every single time. Okay? So we just rewrote log base 5 of 7 and changed it to base 2. So that's log base 2 of 7 over log base 2 of 5. And your original base always goes on bottom. So will you guys try number 4 by yourselves right now? So what'd you guys get for number 4? Log of 3 over log of 2. Good. You don't have to put the 10. You can. You don't have to. Okay? So it's better not to, because textbooks, tests, math in general, if it's a base 10, they won't write it. So just get used to not doing it. Okay. We can also do this backwards. So if you are given log base B of A over log base B of C, we can actually condense those to a single log by dropping that base B. Okay, so let's do 5, 6, and 7. Log base 5 of 8 over log base 5 of 7. The bases are the same, so we can drop that base of 5 and rewrite this as log base 7 of 8. So that bottom number is always your original base. So it just goes back to where it used to be. Okay, so what about number 6? What would that be? Log base 10, so we don't have to write it, right? Of 6. There, we're doing change of base backwards.
Yeah, I know, but why was the 2? Where did the
number 7. If I have natural log of 4 over natural log of 3, natural log is the same as log base e, right? So what I'm going to do is I'm just going to write that e in for right now just to remind us. But what can we do? We can cancel those e's. So what happens to my answer? Is it natural log anymore? No, it's just regular log base what?
Log
Base 3 of 4. So even though our when it was in change of base formula, it's natural log. After we drop those natural logs, we have to rewrite it again as a regular log. That make sense so far? Yeah? Okay. So, what we are going to do for 8, 9, and 10, we want to express the following as a single log, and then you're going to have to simplify our answer as much as possible. Okay? So number 8, how would I rewrite that as a regular log? Log base 3 of 81. Can I simplify that at all? Yeah, I set the whole thing equal to x. So it's 3 to the x equals 81. So that's 3 to the x equals, how can I rewrite 81 as base 3? 3 to the 4th. So then what do I do? Drop the bases. So x equals 4. How do you feel about that? Feel good? Decent? Okay, how about number 9? How would I rewrite this one? Log base 5 of 2 over log base 5 of 8. What can I do first? Shayla, what do I do first? Drop the 5. Of 2. Good. Set it equal to x. So, Matt, what's my next step? Eight to the x, right? Equals 2. Okay, so I want to solve for x here, Michael, so what do I do?
Obviously you need to equate the problem into finding x, so equal to x.
We did that. I'm at 8 to the x equals 2.
Then
This is 8 is the same as 2 to the 3rd, so it would be 2 to the 3x equals 2 to the 1st. Okay, so what can I do, Caleb? Drop the base. 3x equals 1. Very good. So we divide both sides by 3. So x equals 1/3. Okay? All right, number 10. How would I rewrite natural log of 32 over natural log of 2? Log base 2 of 32. So Ashley, what do I do next? Equals x. Okay. Shelby, what's next?
And it's a 2, or, yeah, choose the x power and then equal 32.
Good. 2 to the x equals 32. Danielle, 32 is 2 to the what? 5. Okay. So 2 to the x equals 2 to the 5th. So Wendy, what do I do next? Good. Drop the bases. So everybody, x equals 5. Last 3. Okay. Our instructions here are to solve the following problems for x by introducing logs. Leave your answer in log form. So what we want to do here is rewrite the exponential. Okay. 5 to the x equals 30. I want to rewrite that as a log. How would I rewrite it?
log
Log base what?
5.
5 of
30
30
equals x.
equals x. Is this whole thing equal to x? Did we solve for x? We did, so that was it. That's all I wanted us to do for number 11. Leave your answer in log form. Okay? Now number 12 has a little bit more work to do. How would I rewrite this as a log first?
2.
Log base
Or wait, no.
8 of
Yeah.
equals 2x. Okay, am I solved for x yet?
No.
No, I have to divide by 2 first, which means I divide the entire log by 2. So that is x equals log base 8 of 74 over 2, or we could also write 1/2.
Why do you see 5?
Log base 8 of 74. So you can have two answers here. They're the same thing. And that's all we had to do. What rule is this? Power rule. So you could bring it all the way back in if you so desired. We can leave it like this. Okay? Okay, how would I rewrite 13? That's going to be log base what? E of 43 equals x. Now, I am solved for x here, but I'm not quite done because log base e is actually what? Natural log of 43 equals x. You could have gone straight to there, yeah. And that, ladies and gentlemen, is all there is to logarithms.